All right, class. So today we're starting chapter 5, which is starting with section 5-1, and that has to do with operations of polynomials. But starting at the top, this big chart that you see at the top of your paper has to deal with the laws of exponents. So just reviewing this is all an Algebra 1 concept. But the laws of exponents, starting with the product of powers. So product means that you're multiplying two things together. And as you see in the example, you have x to the a times x to the b, and that's equal to x to the a plus b. So basically, as long as the bases are the same, as long as you're the same base for each monomial, you're just going to simply add the exponents. So you just add a plus b, you keep the base, but again, just add the exponents. So as an example, if I had something like 3 squared, and I was multiplying it by 3 to the 4th power, again, you keep the base, so the base is 3. You keep the base, but you just want to add the exponents, so 2 plus 4 gives you 6, and then simplifying that comes out to 729. And that'd be your final answer. So 3 to the 6th power, 3 times itself 6 times is going to be 729. And now for the next one. So product of powers, if it's multiplication problem, you add the exponents. Quotient, which means now you're dividing. So if you divide two monomials, again, as long as the bases are the same, which they are, so they're both x, now you're just going to subtract the exponents. So it says a minus b. It's going to be x to the a minus b power. So as an example, if you have 9 to the 5th power, and I'm dividing it by 9 squared, and I would get 9 to the 3rd power, which is going to be 729. Okay, so again, you keep the base would still be 9, but just subtracting 5 minus 2, and that gives you 3. Same thing too if it's going to be reversed. So even if you had something like this, I'll give you guys a different example. So even if I had something like 9 squared on top and 9 to the 5th power on the bottom, I'm still technically going to be subtracting my exponents, but since 5 is on the bottom and that's the bigger value, I would actually get 1 over 9 to the 3rd power. So again, just still subtracting 5 minus 2, which would just be the reciprocal 1 over 729 would be my answer instead. Okay, so just make sure you know you're just subtracting the exponents. Wherever the bigger exponent is, that's where your answer is going to be. So if the bigger exponent's on top, then my answer is going to be on top. If bigger exponent's on the bottom, then it's going to be on the bottom. Okay, negative exponents. When it comes to a negative exponent, you never want to leave a negative exponent in your answer. Never, ever. So, as an example, if you have x to the negative a power, as you see, you're just going to take it, relocate it to be downstairs to make it into a positive exponent. So you basically just do the reciprocal. And same thing vice versa. If you have a negative exponent in the bottom to make it positive, then you just move it up top. So as an example, if I have 3 to the negative 5th power, that's just going to be 1 over 3 to the positive 5th power, okay, to make it positive. Or, again, similarly, if you have, let's say, 1 over b to the negative 7th power, to make it positive, it would just be b to the positive 7, just move it up top. Okay, so just do the reciprocal basically, and that'll give you your positive exponent that you want. If you have a power to a power, so power of a power is what it says. So if you have an exponent raised to another exponent, which we worked with in the previous chapter when we had our imaginary numbers and we had like I squared to the 13th, things like that. But a power to a power, you want to multiply. So you want to multiply those two exponents together. So as an example, if I have 3 cubed squared, that's going to be 3 to the 6th power. So I'm just multiplying 3 times 2, and then 3 to the 6th power once again is 729. So just simplifying that. Okay, power of a product. So basically I have two things already being multiplied, like x times y, and I'm raising the whole entire thing to the a power. So what you're going to do is distribute that exponent. You're going to raise each and every single term inside to that power. So as an example, if I have 2k all being raised to the 4th power, what I'm going to do is 2 to the 4th power times k to the 4th power. So I want to raise everything to the 4th power inside, which will give you 16k to the 4th as your final answer. Okay, so 2 to the 4th power is 16, and then k to the 4th just stays k to the 4th. Or same thing with the quotient, so power of a quotient. So again, I already have a division problem. These are being divided. X is being divided by y, but the whole thing's being raised to the a power. Again, you want to distribute that exponent to the top and the bottom, so you'd have x to the a over y to the a. So for an example, if I have x over y all being squared, well, that's just going to result in x squared over y squared. So you want to square everything inside. The next thing, if you have a 0 power, so anything to the 0 power is basically always going to be 1. Doesn't matter what it is. So if it's 7 to the 0 power, that's 1. If it's negative 1,253 to the 0 power, that's 1. If it's 0.12 to the 0 power, that's 1. Anything to the 0 power is always going to be 1. Okay? Our first definition has to deal with a monomial. So what a monomial is, these were all monomials I was working out in my examples up here. So what it is, it could be a number by itself. It could be a variable also by itself. Or it could also be a product of the two. Or it could be a product of a number and a variable. So if you multiply a number and a variable together, that's also technically a monomial. So here are some examples of monomials. So again, it could just be a number, like 5. 5 by itself is a monomial. It could be a variable by itself, like x. So that's considered a monomial. Or it could be a product of the two. So if I multiply 5 times x, that's still a monomial. Or if I had something even as complicated as this, 75x squared y cubed z to the 5th power, that's still going to be a monomial. Okay, because they're all being multiplied. 75 times x squared times y cubed times z to the 5th. So it's all one monomial. The key thing is knowing how to make sure that your monomial is completely simplified by using the laws of exponents. So first of all, you want to make sure there's no powers of powers. So don't leave an exponent raised to another exponent. You want to make sure you simplify those fully. You want to make sure that each base appears exactly one time, so no additional bases. So if you had an answer like this, if you had something, you know, like 5x squared over 2x cubed, you want to reduce down these bases. You don't want to keep those. Okay, so the base should only be there one time. You want to make sure that all fractions are in simplest form. Okay, so basically make sure it's fully reduced. So as an example, don't leave something like 10x squared over 2. You can actually reduce that to get your answer of 5x squared. Okay, and our last bullet point, you want to make sure that there are no negative exponents. So if there's any negative exponents left in your answer, make sure you just make them positive. So don't leave your answers, you know, 10x to the negative 2. Instead, write your answer then would be 10 over x squared. That'd be your final solution. So no negative exponents. And the last thing to talk about with monomials, so how you find the degree of a monomial, what you're going to do if you want the actual degree of that monomial, it's just going to be the sum of the variable's exponents. The sum of the variable's exponents, because you could have more than one variable, so take that into account. So as an example, if I gave you this monomial, x to the 4th power, the degree would just be 4. Okay, so it's just the sum of all the exponents, which there's only one exponent, it's just 4. And if I gave you something like this, ab to the 4c squared, so the degree of this monomial, again, you want to add up all the exponents of the monomial. So you got a to the 1st, b to the 4th, and then c squared. So if you add 1 plus 4 plus 2, so that should be 5, 6, 7, degree would be 7. Okay, or even if you had something like this, 7x squared y cubed, the degree of that monomial would just be 5. So I'm just adding just the exponents. So I'm just adding 2 and 3 to give me 5. So that would be the degree of the monomial. All right, on to the next page. So now putting this all to good use, using and applying your laws of exponents, now you have to actually start simplifying. So the first one is all multiplication. You're multiplying 3 terms together, 2a to the negative 2, 3a cubed b squared, and then c to the negative 2nd power. So first thing I'm going to do with multiplication, you want to multiply just the coefficients together. So 2 times 3, that gives you 6. So that's just straight multiplication. But now with the exponents, you want to add them. So you're not just going to start adding all of them together. You just want to combine the a's with the a's, the b's and the b's, and the c's and the c's. So if you combine the a's, starting with the a, so I'm just adding -2 and then 3. Well, that's just 1. And then I would still have my b squared since there's no other b's, and I'd still have c the -2. Okay, but to fix this, again, you do not want to leave negative exponents in your answer. So you're only going to relocate the ones that have a negative exponent, which would just be the c the -2. So moving that downstairs, your final answer would just be 6ab squared over c squared. So once you move it, now it's going to be a positive exponent. Okay? So number 2, now it's division. So you have your top monomial being divided by your bottom one. So again, with the actual coefficients, the numbers in front, you're just going to straight divide those. That's it. So 24 divided by 3, well, that's just going to be 8 over 1, or just 8. And again, with division, you want to subtract the exponents. So multiplication, like the previous problem, you add the exponents, but now you want to subtract. And again, wherever the bigger exponent is, that's where it's going to be in the end. So with the q's, you have 2 on top, and then you have 7 on the bottom. So the 2 would cancel on top, leaving you with q the 5th power on the bottom, because 7 minus 2 is 5. And now same thing with the r's. You got 4 r's on top, 3 on bottom. The 3 would cancel, and you'd have r to the 1st power left on top. So now if you clean this all up, your answer would just be 8r over q the 5th power. And that would be it. Okay, the next one, number 3. So you have the quotient of -2 a the 4th over b squared. The whole thing's being cubed. So again, what you'd want to do, laws of exponents, is you'd want to cube everything inside. So you want to distribute, again, to each and every single term, you're cubing everything. Okay, so when you cube it all, what you're going to have is you'd have -2 cubed, and then a the 4th would be cubed, and then b squared would also be cubed. So you're cubing it all. Okay, so just taking one thing at a time. If you do -2 to the 3rd power, again, what you're doing is -2 times -2 times another -2. So -2 is +4 times the other -2, you get -8. So on top, I have -8 for my coefficient. And then power to a power, I have a the 4th being cubed. You want to multiply these together, which would make that a to the 12th power. And then on the bottom, also power to a power, 2 times 3, you'd have b the 6th power. And that'd be your final answer. Okay, for the next one, for number 4. So the whole thing's being raised to the -3rd power. So you can kind of do this one of 2 ways. You can go ahead and distribute, like you did in the last problem. Distribute, so you would have a to the -3 over 4 to the -3. And now you got to flip it. So if you move the bottom to the top and the top to the bottom, you'd have 4 cubed over a cubed. And now you want to actually simplify what is 4 cubed. Well, that's 64 over a cubed is just a cubed. So you could do it like that if you wanted to. Or even from the very beginning. So if I have a over 4 to the -3, I can make the whole thing positive now, a positive exponent, if I flip it from the very beginning. So if I move it from the very beginning to be 4 over a, now it's being all raised to the positive 3rd power, and now distribute afterwards, doing 4 cubed over a cubed, which is the same right above, you still get to the same answer of 64 over a cubed. So however you want to do it, it's kind of up to you. I actually probably prefer the second way, especially if you have a more complicated fraction inside. So if it's more than just a over 4, if you have something more complicated, it's probably easier to flip it first and then go through and distribute, but it's kind of your guys' call. Okay, the next one, number 5, going back to multiplication. So again, you're just going to multiply 2 times -7, so just multiply the coefficients, that'll give you -14. And now the exponents with multiplication, again, you're trying to add the exponents. The x's with the x's and the y's with the y's. So for the x's, if you add -3 and 5, well, that gives you +2. And then the y's, so I'm trying to add 3 and -6, that's -3. Okay, but now you got to fix it because you got a negative exponent. So again, you're only going to relocate the y to the -3. That one moves downstairs. So your final answer would be -14x squared That'd be over y to the positive third power. Okay, and the very last one, so we have the quotient of 6c to the fifth d cubed, and that's all over negative 3c squared d to the seventh. The whole thing is being squared. So you have to square everything on the inside. Okay, but again, you could kind of do this problem one of two ways. I'll show you guys both ways. So if you want to square everything first, distribute, square everything first if you want to. So again, you'd have 6 squared, and then c to the fifth would be squared, and then d cubed would be squared. The bottom, you'd have negative 3 squared, c squared squared, and then d to the seventh squared. Okay, so now simplifying. Okay, we got 6 squared, so that's 36. And then c would now be to the 10th, because again, you got to multiply. D would now be to the 6th, again, you got to multiply. On the bottom, negative 3 squared would be positive 9. And then you'd have c to the 4th, d to the 14th. So again, just multiplying those exponents. Last thing now that you'd want to do is reduce it. So if you reduce down everything, so just doing the 36 over 9, well, that's just 4. So that'd be a 4 on top, 1 on bottom. The c's can reduce down, so if you got 10 on top, 4 on bottom, the 4 would cancel, and you'd have 6 left on top. So I have c to the 6th power. And now for the d's, well, you got more d's on bottom. You got 14 on bottom, but only 6 on top. So d is going to be on the bottom. The 6 would cancel, and if I do 14 minus 6, well, that just gives me 8. So over d to the 8th power. Okay, so that's one way you could do this problem. You could do it another way too. So if you wanted to, you can also do it a second way. So I'll show you guys that way. So we have 4c to the 6th over d to the 8th. So we should get to that same answer. Okay, I'm going to clear everything out right now. So again, it's 4c to the 6th and then d to the 8th on the bottom. So getting to the same answer, if you started out like this instead, if you reduced everything first. So if I just reduce everything that's in the inside first and then square it afterwards. Okay, same exact answer. So if I reduce it first, so if I do 6 divided by negative 3, so that'd be negative 2 over 1. Reducing down the c's, so the 2 would cancel, and I'd have c cubed on top. Reducing down the d's, well, the 3 would cancel on top, and I'd have d to the 4th left on bottom. So right now I have negative 2c cubed over d to the 4th. And now I'm going to square everything. So if you square everything afterwards, distribute, squaring everything inside, you would have negative 2 squared. And then c cubed would be squared over d to the 4th. And that's being squared as well. So if you square everything afterwards, you still get to the same answer, because negative 2 squared, that's positive 4. Negative 2 times negative 2. C would still be to the 6th power. Again, you got to multiply. And then D would still be to the 8th power. Okay? So same exact answer that we got before, but just a different way. And I actually probably prefer this way as well. I would probably rather reduce it first and then square it all. Just kind of makes life a little bit easier. Okay, it's not going to be such a big of a mess when it's all said and done. Okay, so we got monomials down. So now moving on to polynomial. So a polynomial can be kind of one of 4 things. It could be just a monomial. So a monomial technically is a polynomial. So a number by itself, a variable by itself, or even something like 5x, a product of the two, that's technically a polynomial. A binomial is technically a polynomial. So if it's a binomial, we're just talking about 2 terms, because bi means 2. It could be a trinomial, which is 3 terms. So tri means 3. So 3 terms. Or it could also be 4 or more terms. So if you have 4 or more terms, it's definitely a polynomial. But a monomial, mono just means 1. Binomial means 2. Trinomial means 3. But if you have 4 or more terms, then it's definitely a polynomial. And if you want to find the degree of a polynomial, the degree of the polynomial is going to be the degree of the monomial with the highest degree. That determines the degree of the polynomial. So whichever one has the highest degree, whichever monomial in that polynomial has the highest degree, then that's going to determine the degree of the entire polynomial. So Doing that, for example, determine whether each expression is a polynomial. So first of all, is it a polynomial, yes or no? And then if it's not, or if it is a polynomial, then state the degree of the polynomial. Okay, so for the first one, yes it is. This is actually a polynomial. It's a binomial, but it's a polynomial. And now to find the actual degree. So what's the degree going to be? So again, you want to find the highest degree. So you got two monomials. If you split this up, there's two monomials in this binomial. So if you find the degree of the first term again, it's just the sum of the exponents. So if I just add 4 and 3, well, that's 7. And then this guy is just 5. So the degree would have to be 7. Whatever the highest degree is, that's the degree of the entire polynomial. Okay. Number 8, though, however, this is not a polynomial. The reason why, the square root of x, that is not a monomial, so it cannot be a polynomial. And same for the next one. This is actually not a polynomial. The reason why is the negative exponents. So having that x to the negative 3 and having that x to the negative 2, those are not monomials as well. If anything, it's going to turn it into a quotient. So if you have negative exponents, it's technically not going to be a polynomial. And then for number 10, this is a polynomial. There's no negative exponents, there's no square roots, nothing funky about this. So yes, it is a polynomial. But now what's the degree? So again, you want to add the exponents of each monomial. So if you add 5 and 1, that gives you 6. And then 4 and 4, that gives you 8. The last one would be 2. So as far as the degree goes for this one, again, the highest degree would have to be 8. And that's the degree of the entire polynomial. All right? So now we got to do some operations with polynomials. So on to the next page. Last and final thing here. So we have two polynomials, the 4x squared minus 5x plus 6. So that's our first polynomial. It's a trinomial. We're subtracting from it 2x squared plus 3x minus 1. Okay, so with subtraction, it's pretty simple. You're really just combining like terms, but you want to make sure that you subtract each and every single term. So you have to almost distribute that minus sign to all three terms. So if you distribute it, you're going to have 4x squared minus 5x plus 6 minus 2x squared minus 3x plus 1. So it's going to change all the signs. And now just clean it up. Combine your like terms. So 4x squared minus 2x squared, it's 2x squared. Negative 5x minus 3x is negative 8x. And then you got the plus 6 plus 1. So plus 7, and there you go. You subtract it. Now you're done. So same thing for the next one for number 12, except this time we're adding. So there's a plus sign in between. So you want to add these two together. Again, just combine like terms. So we got 6x squared. We're adding negative 4x squared. So that'd make that 2x squared. And then we got negative 7x. We're adding to it positive 9. So that'd be 2x. And then we got the plus 8. We're adding negative 5 to it. So if you have 8 plus negative 5, that gives you positive 3. And there you go. So same thing for number 13, going back to subtraction again. So again, make sure you distribute that minus sign because you're subtracting all three terms from the first term. So if you subtract, you got negative x squared minus 3x plus 4. After you distribute, you'd have minus x squared minus 2x minus 5. Again, you're subtracting everything from the first one. So that would give you negative 2x squared minus 5x minus 1, just combining like terms. And then same for 14. Now we're just adding. So going back to addition, combine like terms. The only like terms we have, though, are the negative 6 plus 1. So everything else just stays the same. You still got 3x squared. You still have that minus x, but negative 6 plus 1 gives you negative 5. Okay, so again, your goal is just to add them, so don't start trying to factor or do anything else. You're not doing that. You're just simply adding or subtracting the polynomials. Okay, and the next one, though, finding each product. So now we want to multiply. So for number 15, you just want to distribute. So 3x to all three terms. So if you multiply 3x and 2x squared, that's going to be 6x cubed when you multiply. So x times x squared gives you x cubed. And now 3x times negative 4x gives you negative 12x squared. 3x times 6 gives you positive 18x. And again, you're done. That's it. So once you're done multiplying, again, don't try to factor it or do anything like that. Your goal was to multiply, and you did that. So you distribute to all three terms, and then you're done. So same for 16. Just distribute 4 thirds x squared. So to the first term, 4/3 times 6, well, that would be 24 over 3, which would give you 8. And then the x squared times x squared is x to the fourth. So now distributing to the next term. So let's see, 4/3 times 9 would be 36 over 3, which makes that 12. And then x would be cubed. So x squared times x. 4/3 x squared times negative 12 would make that negative, what is that, 48 over 3. Negative 48 over 3 then gives you negative 16, and that'd be x squared. And there you go. Okay, whereas number 17, now we're multiplying a trinomial times a binomial. Okay, you basically just want to FOIL here. Same exact idea as foiling. So what I'm going to do is I'm going to take this x squared, I'm going to distribute that to both terms first. So if I do x squared times x, that's x cubed, and then x squared times 2 is 2x squared. Okay, so I'm done using that. Now I want to distribute 4x to both terms. So I'm doing 4x times x, so positive 4x squared, and then 4x times 2 gives me 8x. So I'm done with that one. And now just distribute negative 6. So negative 6 times x, negative 6x. Negative 6 times 2 gives me negative 12. And now I'm done multiplying. So I just need to go back, clean it up, combine my like terms. So we just still have that 1x cubed, but we have these x squareds, which would give you 6x squared. And now we have 8x minus 6x, which is 2x minus 12. And that is it. Okay, so same thing for number 18. So I'm just going to take this x, distribute it to all three terms. So now it's just flipped around. Before it was the trinomial in front and then the binomial that followed, but now it's the binomial times the trinomial. So distributing x to all three terms would give you x cubed plus 4x squared plus 16x. So we're done with that. And now distribute negative 4 to all three. So we'd have minus 4x squared. This would be minus 16x, and then minus 64. And again, just clean it up. Combine your like terms. So you got your x cubed still. The x squared, so we got positive 4x squared minus 4x squared. Well, those cancel. And then we have positive 16x minus 16x. Those cancel. All we have left is minus 64. And this is actually something kind of special here. We're going to learn how to factor these eventually. But this is what's called a difference of cubes, which we're going to revisit later on in the chapter. But it's called a difference of cubes. It's the difference between two perfect cubes. X cubed and 64 are both perfect cubes. But now 19, again, just distributing, FOILing this out. So 3x, if I multiply by the first one, that'd be 6x cubed. And then 3x times negative 4x is negative 12x squared. 3x times 5, that's 15x. So we're done with that. And now distribute negative 1. So you'd have a minus 2x squared plus 4x minus 5. And now combining like terms, 6x cubed. Your x squareds would make that minus 14x squared. And then your x's, 15 plus 4 makes that 19x minus 5. And there's your final answer. The last one, number 20. Okay. So for this one, you have three binomials being multiplied. You can't multiply all three of them at the same time. So you can only do two at a time. So let's just say we want to multiply the first two. So if I just do 2x plus 3 times x minus 1. Okay, just do two at a time. And then once we have that answer, then we're going to multiply it by the third term, or the third binomial, the x plus 4. Okay, so just foiling these two together would give you 2x squared minus 2x plus 3x minus 3. So you'd have 2x squared plus 1x minus 3. Okay, that's what we get from the first two. Now take this and multiply that by the third binomial, the x plus 4. Okay, so just to finish this out, multiplying those together, you would have 2x cubed plus 8x squared. So I'm done with the 2x squared. Now distribute x to both terms, so you'd have a plus x squared plus 4x. Done with that one. And now distribute negative 3, so you'd have minus 3x minus 12. One last time, clean it up. You got the 2x cubed. The x squareds would be 9x squared plus 1x minus 12. And there you go. Okay? So if you guys have any questions about this in the future, to let me know. We can go over some questions obviously on the homework next time, but now it's time for you guys to practice and get your homework done.